like, this is why it's a green screen right now. Sounds like, this is why it's a green screen right now. Oh wait, sounds like, this is why it's a green screen right now. Alright, what does it sound like? Alright, what does it sound like? Alright, what does it sound like? Oh damn, picking up on the desktop. Wait, let me turn it off. Okay. Alright. How well is it? Test, testicles. Is this better? This way? I don't know. Wait a second. What if I turn off the filters here? Separation level. Like this, maybe? Is this better? No? Alright. Completely off. Okay. Hey, this sounds really better. Why has this been on at all? Okay, I'm gonna try the other mic for now. So the HD camera. Okay, is this better? Oh no, it's totally bad. It is bad. Okay, glad it's bad. Can you bring it back away from me? Put it like this. Set it here. Does this sound good? It's not bad. It could get louder, I guess. It could benefit from a lot bit of. What is this? I think. Let me see. Is there a expander? What does that do? Oh. Okay. Nope. No, I don't like it. Compressor, yes. Compressor should be a little bit better. I wish it was a little bit faster than this. So maybe increase the threshold, the ratio. I don't know. The gain at the end, probably now. I don't know, but it's a bit hard. Oh, okay. Test again. So there should be a live feedback. Let me Google if there's a live feedback. OBS live feedback mic. Oh, okay. Right, so settings, audio. Wait, where is it? Oh, in the properties. Wait. So here, properties. No, it's not there. No, I don't. That's not what I want. What if I lean back? Is the leaning back? Does it sound okay this way? Like here, just pretty far now. No, it's totally fine actually. Wow, That's pretty interesting. And quite near. Now, if I talk like this, is it a bit better? And yeah, I mean, here I can't yell, I think. You're not allowed to yell. Ah, well, still, the limiter works. I can hear my own feedback from my headphones. That's pretty cool. Okay, so we have that. Get it back to where it were. And I think farting is also audible here. Audible.com. It's not sponsoring us. Okay. Now, let's plug in the music. And I think I could start. But hi. Good. Okay. So we're live, and things seems to be working fine. I'm gonna. Do I look good? Do I ever not look good? I mean, come on. Let's reset the clock. And we're doing fine. And I don't think we need that much sound. Oh, yeah, I can mute this actually. Good. Alright, so welcome back, ladies and, well, nobody. There's nobody watching. So I'm gonna set up some music here. Okay, so where were we last time? What were we doing? Oh, let me. Okay, so we had the cell and an equilibrium. And pH counter. Yeah. There's a couple of stuff I could do now. If we look at the plan, where is the plan? I don't know. Welcome. Oh, 3 times. That is interesting. Yeah, I don't care. It's working. So 3 times is at least I'm getting it something. So let me rename the stream to actually not living cell, to simulating a living. There you go. Now, let's get back to the plan. We have slot to display symbols. After inventory button does jack shit. Um, I wanted to make console commands, but I don't know if I want to do it now because it's an entirely different thing. Like I have to simulate. I have to run. It's interesting though. You have to detect the buttons. You have to render words and execute commands and parse them. Like the console command itself, it's gonna be its own three episode at least. 3 episodes at least 3 hours an episode. Should be around 10 hours of work to get it to basic functionality that I can just get done right now. The thing is, there isn't much to do with the like it's not gonna help me that much. So far up until this point, it's not gonna be worth 10 plus hours to put into it to just get it working out of the very few functionality we get out of this. Preferably I'll add it later when I want to do testing, because if I want to create multiple all kinds of different levels and want to test different combinations of things, and yeah, I want to do that, then I could do the testing that way. I need console commands to constantly be changing values in the game to try and break it, try and push it out beyond its limits and see how things work. So it's probably going to be in the near future, not that far away. Graphs would be also interesting to have graphs, but this is also part of the core gameplay. But for now, we need to get the simulation to be at least somewhat done. So FERT-ish. So yeah. Alright, I'm saying them. Mm-hmm. Okay. So there's a couple of things we want. For now, we have transporters, and we have basic factories, so like synthesizers. I mean, which we could also call enzymes, right? So these factories are also enzymes. Yeah. They accelerate a certain reaction. But I'm not gonna go into semantics here of what's an enzyme and what's an actual protein that produces things in a certain way, because enzymes are proteins, and are they catalysts? Are they like, what do you call an mRNA actually? The RNA ribose. What is a ribose? I mean, what's the scientific definition? Not a ribose. Polymerase, right? Yeah. It's a protein. It's an enzyme. It's always an enzyme, actually. I could call factories enzymes. This could maybe make things a little bit at least distinct things away from me. You know what? Let's call them that. Let's do a basic rename of all this stuff. So in the sim, in the cell, we have a factory. Let me rename this to enzyme. And the E factory is energy, or E synthase. All this E synthase enzymes. Because they are enzymes, right? Yeah. Energy consumptions, total E. This looks a little bit more like actual cell biology now. So, what do we do next? What do we do next? So we have enzymes, and we should have storage units of some sort. A storage unit would be then, in this case, if we simplify it, I mean, there's a lot of ways cells actually store things in them, but a simplified version is, at least for energy, we could store them in form of fat. I mean, yes, there are sugars and there's fats. We could do that as well, I guess. And maybe we can come up with a new form of a new element, and that element would be, I don't know. We have certerium. We call it certate or something, and that is like a storage form of that sugar-ish thing that we come up using sultrium and carbium. Yeah, I guess we could do that. But then we'd have to make a new storage, because it's gonna be like within the cell anyway. It's gonna fly around within the cell anyway. And what is the benefit of having it in that form, if all we're going to do when we're going to actually use it is just burn it away? Like transform, use energy to transform it back, and then use again energy to use it. So what's the point? I could just skip that and get it to that level. Now we can have fat. Fat is something that we could regulate. Maybe within the one cell, of course, there are fat cells as well. We're not going to do that. To simplify things, I'm going to make like usually in cells as well, you'd have fat storage units, follicles, whatever. It's going to be something like that. They store energy. And the more energy you have in the cell, like cells should have a certain concentration of energy in it. And yeah, we could call the energy something else. Like maybe we could call it energium or something. I mean that number is gonna have to be stored somewhere, right? And it's gonna have to be also a concentration, because in the end we're gonna keep an eye on the volume. So maybe we should switch to a system that uses energy. And yeah. By the way, since we're where's the test? I think it was Bin data text test. Yeah. Yeah. I mean, I could add all the list of things here. Deuterium. I think it was CYR. Now, if we're gonna store it in forms of fat, we gotta have the distinction between like Deuterium and fat, right? I mean, maybe we have Deuterium and Deuterium makes. We need fatty acids. We need fat, basically. What's fat in Latin? Crassus. What is it? Let's call. What's Greece? Greece. Not Greece. I mean Greece. Really? Arvina. Arvina? And does Arvina mean anything? Images? Nice. Yeah, it is. It is that. It is that. Okay. Okay, so we can add Arvinium, right? Basically that. So I'm gonna. By the way, this is just text from me. Just copy it. Arvinium. Molecule. What do you call it? A fatty molecule that is produced when product of broken complex fats. I am coming up with my own shit here. This does not, disclaimer, this is not scientifically accurate. But that's the fun of it. Where's creativity if you don't, you know? I mean, if I run it now, the whole thing is just so that when I do this, I can find these things here. I want to see them here. And the parser needs still some work. So let's add Arvinium. Oh, by the way, there's another thing I need to be working on. How to deal with concentrated. Because that is another thing. Because the concentration... You know what? Or I could... which actually sounds a bit better. Hear me out. Right now I have a system that, based on how much water and how much saltrium, for example, it produces concentrated saltrium, concentrated saltric acid, non-concentrated saltric acid, and so on. Now, how do you deal with solutions as well? solution is also water. The thing is, slots work a bit differently than the way the cell works, because the cell doesn't have per se Celtric solutions, although they're all it's a solution like inside the cell, the intracellular cellular room. No. What do you call it? All right, we gotta look something up. What do you call it in English? Extracellular space. Yes. Space. Welcome to space. Alright, so okay. That's a problem for tomorrow. Let's or later today. Arvinium. Let's add arvinium for now. Where's source? There's a lot of things if you're noticing right now. Impure Certerium. You see, do I want to deal with that is the question. Do I really want to deal with the hassle of is it impure, and how do you even translate that into, like, when you're adding to a cell? I mean, I could basically do this. I mean, I could just say when adding to a cell, if it is a diluted certerium, if it's a diluted carbic acid, how does the cell, react to it and whatnot? Would it then add water with it? You know what? It would. It would. Yeah, that would solve. I think that would solve the problem. I mean, there's carbic solution, carbic acid, and carbic ice. High density, low density just means the rest is just bullshit. The rest is just water. And do you want to just add water, or do you want to just make it concentrate? And the tricks will be then you have to mix like highly concentrated carbic acid with diluted with a diluted Celtric solution to get this weird new thing. Okay, so for now let's add arvinium. Did we agree on arvinium? Arvinium. Is arvinium at all a word? Nope, it's not. It's not. And if I insist, nope, some weird shit. Okay. Okay, so I should be careful when I'm googling things. I'm live here. All right. So arvinium. Arvinium is like basically acetyl coenzyme A. I feel like I could put it here. Okay. Does this look good? Nice. Does this help? Nope. It's a problem with prepositions right after the thing. Yeah, we'll get to it later. Arvenium, which is just fat. You could also add complex fats and simple fats, and you know, make them produce acids and all that kind of stuff. A lot of fun little nuances we can add to this little cell. But for now, let's stick with Arvenium. Are we running the clock is running? Okay, so okay, let's go to initialize and make. Actually, let's get this okay, I'm gonna make it then 0.9. What's the cell volume usually? What's a typical cell volume? Pretty small. You know, I just eyeball it by 15, or I actually by 10, right? And Arvenium, also 10. Arvenium is just the it's just whatever is used for energy, basically. I think. What else did I call it? It's ATP is not acetyl CoI. Deuterium. Actually, let's make this produce Arvenium. An energy rich molecule that is produced a product of broken complex sugars. Basically ATP, actually. But this is only note to self. I'm not gonna keep it in the actual game. Because I don't want it to go down that rabbit hole. Now let's add another transporter for Arvenium. Actually, no. Arvenium wouldn't be pushed. That's the thing about the Arvenium. You don't push it out of the cell because there's no way to. You should pack it somehow. So there should be a factory. Let's add a factory. Actually, a factory, an enzyme, basically. This is a factory. And I want something like this. Again, another enzyme. Actually, here's the thing. Target C. The target C could be just different from the thing it is. Ah, that's actually a cool idea. So, target C element. So here, target C. Target C element is Certerium here. Try to increase the amount of Certerium. Right. Now, here, we just make the target C element is Arvenium, and it has to stay 0.05, right? Actually, keep it 15, right? Should be high, for example. Energy consumption is 1. It's very simple transformation. The reactant in this case either I could put them in transporters or just make them fat. That basically it. What's another word for fat in Latin? Latin dictionary. Lard. Fat. No, grease. Huh. Oh, Latin English. I want English Latin. Fat. Oh, adipose. Adipide. Adipide. Adipose. Nah, adipose seems weird. Just call it fat, I guess. I mean, Jesus, it doesn't have to be rocket science. Okay, so we have this thing that tries to keep this the way it is. It takes RVM as a reactant. And spits out fat. I don't want any byproducts actually. Fatty acids. What are fatty acids? Yeah, they're yeah. All right, let's call it like this. Alright, so we'll have fatty acid. Okay. Now I want fatty acid 1. The product will be fat. The target element I'm working on is arvinium. Is going to be like this, and that's it. One enzyme that turns arvinium into fatty acid. You could also have another enzyme that turns fatty acid into arvinium. Yeah. Which needs energy to turn it, because it's not the most efficient way, because it needs there should be a better way. The better way to do it is also had the specification of how many of each molecule they're going to take and how many you're going to output. basically, yeah. Back to the drawing board. Byproducts amount, and element here is going to be int of byproducts amount is going to be product. Amount, and reactants is going to be amounts. Target C. Okay. There's a lot of stuff here. So let's say the first one the amount is going to be, I don't know, it takes 4 and produces 1. And product amount is going to be 1. No, here, wait, what are we talking about here? So arvinium it takes from arvinium to fat. No, you don't produce fatty acid that way. You just produce fat. You don't produce fatty acid by storing fat. So here there won't be any other products. So I need to check if by product is null pointer. If so, also check for amounts of in and out. These have to be done to be added to the function that executes this code. That updates. So we have an arvinium for the product fat is 1. Here you take fat, the reactant is fat, and the reactant's amount is 1, and you spit out three. Nope. No, this is fatty acid. You spit out 1, and you spit out from here 3. Product is going to be fat. The amount is going to be, no, the product is going to be arvinium. It's going to be 1. Oh, 3. To produce 3 arvinium, And one fatty acid is a byproduct by burning one fat, of which you use one energy here and one energy here. Enzyme target C of arvenium is the same. It's the same target. So one of them burns, one of them does not. Actually, wait, what would push it to do that? So you have, let's say you're taking in way too many fats, way too much fat. You try to keep the arvenium low. You could increase the fat. You could try to keep it low. But at some point, the fat levels would be higher and higher and higher the higher you push into it. It's just gonna keep trying to keep arvenium at a stable level. I don't know. I want to try this first. I want to try this and see how this one will work. Da da da. All right. Let me just add another transporter. The same thing, but for fatty acid. The E synthase is going to be another factory. I use my GPU a lot. I love that this thing is spitting out 3 times. Why are you spitting out 3 times? I'm trying again. Great. I don't know. Okay, so so yeah, if we're gonna simulate the power, I'm not gonna have an E synthase anymore. It's just gonna be. Yeah, you can. You can't have it integrated, running on the laptop. Is integrated. Sure, the GPU is a GPU. It doesn't matter which one you're using. So if it's a GPU, if it's an integrated GPU, then it should run as well. Provided you have the drivers, which is another issue. But I don't think like SDL is a versatile enough to run on any GPU. I mean, I was using my laptop for that before, and now I'm using a normal PC. But before I used to have using just to render this on a laptop, and it would run fine. As long as it's like, you have the drivers for it. You should. What? A thin? What's a thin? Oh. Right now I am... Alright, let me show you my specs. I have a Core i5 9th gen CPU, quad core, pretty decent. And I have an RTX 2060. This is a gaming laptop, a gaming tower PC. It's not a laptop. I used to use it on a laptop, but yeah. And right now it's the GPU is running because I'm decoding the OBS is running on it. But like if I run the thing, if I run the actual game, there's like a, you don't even see it, the spike in rendering. And yeah, I don't monitor the things from here. The laptop had, this was pretty old. It was pretty fucking old. I think it was from 2012 or something. It was an i3 4th gen or something. I can't remember. but it was pretty old. Why are you asking? What's exactly are you wondering about? What are you interested in? Oh yeah, I installed an SSD in it before it had a hard drive, and it was pretty bricked. It was really shitty. I couldn't run an OS on it because it was so old and slow. I found it once in the closet, and I thought, hey, maybe I should check it out why it wasn't working anymore. And it was just I need a new hard drive. Put in a very cheap SSD in it, and it ran pretty smoothly until I wanted to actually, live stream and also run code and compile and debug, and it was pretty slow when it came to the CPU and hard drive. So I just switched to using my gaming PC for this. Okay, so where was I? Oh. Yeah. I mean, GPUs are really not important if you're. I mean, it depends on what you're gonna do with it. If you're gonna be programming, most programming things you don't even need. Like if you're working on C code and you're, what is? You should ask yourself what you really are doing. I mean, if you're gonna be programming Unity and and I don't know, like really graphically advanced games that needs a lot of graphical power, then you might need a good GPU for it. But it's much smarter when you're programming to put all your money, not all your money, most of your money into a good CPU and good fast drives. And sometimes a lot of programming laptops don't even have a GPU, and they work perfectly fine and actually pretty amazing. Like you see an i9 laptop with a 2 terabytes M.2 SSD, and it's working amazing, and it doesn't have a GPU because mostly you don't need it. I think it does have an integrated GPU, of course, but I mean, that's how would you else render things? But basically, like if it could run the game that you're trying to program, then you could work on it. That's all there is. Like, look at my game here. It's gonna be a 2D game. It's basically all math inside. That's the work I'm doing. All this is just on the simulations and the numbers and stuff, and not much on the GPU itself. Yeah, you definitely don't need a good GPU for that. You definitely don't want that unless you're interested in playing games. But no, a good GPU is not necessary for Android games or web development. Okay, so this. Okay, one now. That's another enzyme that turns. Oh yeah, Cerium. A reactant. One reactant, Cerium, takes one and spits out. It has no byproducts, and it spits out 2 arvanium. 1 arvanium. 2 is a bit fast. Actually, 2 is good. HP 14. What are the specs on that thing? $5,300 was it? 3.5. Oh god, I don't even. I've never used a Ryzen. I want to look up what's the Intel equivalent of this one. What is it? 2.6 gigahertz. Actually, I don't even look at the equivalent. I just want to look what specs. For 2.6 gig. Looks okay. God damn, if it has an integrated graphics card, then that should be really good. Mm-hmm. It uses 1 energy, I don't know. To burn fat, you need Lenovo, Legion, GTX. What? GTX 1650? What? Is that a 10? Oh, what are the specs of that one? Yeah, oh god, they're just... But honestly, you don't... I mean, good lord, you don't really need that. You don't need that. You don't need a GTX 1650 if you're not going to be gaming. Yeah, I mean, no wonder that costs so much difference. You don't need it, honestly. Unless you're planning to game on it. I mean, you are going to be miss out a lot of stuff. Like, you want to run this thing, and you want to play that thing, and you want to try that program, but none is going to work that well because you don't have a GPU for it. But if you're just buying it for work or for university, then that's just for that. If you have a gaming computer or gaming laptop at home, then just go for the one that doesn't have, unless that's your sole only thing. I mean, if I were you, and I only had just one computer to buy, nothing else, I would probably buy the one with the GPU because I play a lot. I want to have freedom to just, what if I want to test out something like that? What if I want to play a game? But if I already have a tower PC at home or a laptop at home where I game, then for work you don't need that. You know? So you take Certerium, pick a Arvinium. Yeah, I don't know much about these, honestly. I don't want, I want to give you advice that I don't know about. That much detail, I don't know. Just in general, I'm telling you. Oh, then you're good to go with that one, without a GPU, without a GPU. And it is cheaper. You can, I mean, if you're okay with putting up $1,000, then might as well invest in an even better CPU and in larger storage, with faster storage, even more importantly, and better peripherals, like how many, like USB Type C, and make sure it has an Ethernet port. Usually they all do, but it's not an Apple. And you know how good the screen is. The battery life is very important if you're planning for work. There's a lot of other stuff to consider other than the GPU if your work is programming. Well, that's great. 16 gigs is good. Like right now, running Visual Studio Code and basically like just a running program, I'm using around 8. Like, this is really not much. 16 would run you amazingly. Yeah, I expected as much. Like, invest in larger battery and faster CPU for the future, because that CPU is the problem when it comes to how long the lifetime of a computer is, because of a laptop, not a computer, not any computer, just a laptop, because they're all soldered in, and it's just this one board. You can't upgrade the CPU. You can upgrade storage, you can upgrade RAM if it was modular RAM. Some of them do have that, but the CPU is just like the computer. And if you buy one that just is way faster for now, then this will be like 5, 6, 7 years later, you wouldn't really need more, which is a good investment, honestly. I mean, basically, like I said, that computer, the laptop, it's from 2012, even before that, and I bought it used, and I still was able to program on it 10 years later, just because the CPU is still okay. It's still good. I just had to upgrade the RAM from 4 gigs to 12 gigs and upgrade to a SSD. Of course, it still had its age, and I think the problem was also with the SSD, and it was really overheating. Like, the whole thing is really old. A lot of dust. Wait, I don't know. Let me see. It says here Core i3. I'm gonna turn it on. I'll tell you in a second. I mean, it's booted from nothing within this 15 seconds that I just talked to you. It's working. Like, it's old, but it's working. And it could go even faster if I invested in a better SSD. Let me tell you, Task Manager. Just a second. CPU. i3. There it is. I'll type it in. Yep, I installed an SSD on it. It's an Intel Core i3 311M. It is quad core at 240 gigahertz. Oh wait, I mistyped this. I meant i3 3110M. Yep. Yeah, and that's way better. I mean, I had like a third generation i3. SSD will change your life. It might blow your. I mean, here's the thing: if you just think that your laptop is slow, just pay $30. Like, don't go over $30 and buy an SSD off Amazon, and just plug it in and see if there's a difference. Your mind's gonna be blown at how much faster the operating system, everything is gonna run. Like, a friend of mine was going to throw his laptop out. He was gonna pull his hair out because of how frustratingly slow the thing was. And I just told him, just please put an SSD in it and try again. And now the dude is happy with it. He no longer wants to buy a new computer because it works. If the problem was only that, it might be just only that. I mean, how much RAM is it? You're also going to check out if it's a modular RAM, because if you open it from the back and check how many slots, some of them like have slots where you can take out like small RAMs. And for, I don't know, $25 you can get yourself like a single stick, 8 gigs or higher. I mean, basically where you get it. And you can boost your RAM and boost your performance reading from disk. I mean, if the operating system is not running on an SSD, the whole computer is going to be just as strong as the slowest chain. Yeah, I mean, right now 8 gigs is basically the minimum to run any operating system right now. I mean, Windows already takes on its own 2.5. And the problem is that Windows 10, you feel like it's not even designed for HDDs anymore. It's like they run constant updates in the background, constantly moving things from here to there. Like, so that Windows run faster for you, they keep moving things in the disk to be organized in a way that makes access to them faster so that you can get to them quicker. Which sounds in theory good, but if you have an old hard disk, it's gonna be chugging and it's gonna be so slow all the time. Dude, why you don't need, if you have a dedicated GPU and an i5 and just get an SSD and try again. You might not even need to get a new one unless it's broken. And if you're still like insisting on like, you know, using it, at least like put an SSD and sell it. Would get you a couple of bucks. Arvinium. What was I gonna do? Well, shit. If the screen is broken, then it's broken. I think at least you can still salvage the hard disk, no, but the RAM. If you're savvy enough, you can salvage the. Nah, not worth it. Just get a new one. Okay, so I'm not gonna be using the eSynthase anymore. No, I mean, if it's not worth it. I mean, if it's gonna be costing you as much as like half a new one, then it's worth to just buy a new one. Oh, you're right. Actually, you're right. You could do, if you have a monitor at home, you can make it into like a home computer. Plug a monitor to it, just get a new SSD to it, and then reinstall like a fresh system on it, and it'll be like a new computer. That's true. You can't take it with you to university. That's the problem. But yeah. Okay, so move this one here. Wait, is my camera frozen? That's damn it. What's the deal? There you go. Shit. Okay. So, what was I going to do? Okay, so I'm going to go into the update function right now. And I'm gonna... Here's the initialization. So we have an enzyme byproduct. I'm a bit lost now. Just want to see where I am. This one pushes the fatty acids out, the carbic acid out, and the sulfuric acid out. This one pulls carbium and sultrium in. Good. I have to add like special conditioning for cases where there's low cell energy, but there's also like low fat. What? Can you use that laptop with somewhat similar speed as this PC? What do you mean? Like how fast this thing here executes? I don't know. I mean, that's a bit... You can't know that. I mean, this PC is much faster than the other one, the one I used, sure. But this again is like, I bought it last year and the other one is 10 years older. And, you know, and still it was like the CPU was doing fine actually. Like, of course, right now the game uses basically like 1%, 1.5%. And this is in debug mode also. And on the other one it was using like 10-15%, like 10 times more, if we could consider it that way. And yeah, here it's much faster. It's much faster to compile, much faster to execute, but it wasn't like useless. I've done half of this project on it so far. Yeah, always, of course, but again, it has like a lot of things are new in this one. Of course, you notice the difference. The operating system runs a lot of things faster, copying things faster. But I also have like an M.2 SSD on this one, and I have like, yeah, it is better, sure. Where it's not useless and it wasn't annoying. The only annoying thing was the heating and the slow SSD, which was like, it was a cheap SSD, which was still by heaps faster than otherwise. And also, like, I was running like 15 different things on it at the same time. Oh, definitely. No, web browser Explorer works fine. You can use it, definitely. I wouldn't be programming on it if I can't use a basic Explorer on it. But keep in mind, Firefox, Chrome, they use a lot of RAM. And mine had like 8, 12 RAM, which was like, it was touching the limits. Like right now, I am around 8.4 RAM. On an 8GB RAM computer, this will break your computer. You can't run so many different things at the same time. So I had like to strategically turn on and off. I don't know. The problem with Microsoft Edge is that it doesn't have that much. Yeah, but Firefox is open source, and I don't want to, I don't know. I've been using it for a while. Microsoft Edge, the problem with it is just it doesn't have that many extensions as Chrome is really, yeah, indeed. Chrome is faster than a bit faster than Firefox recently. But again, Chrome is Google, and Google is shitty, and Firefox is a little bit, But mostly it's just the functionality of it. Like I have a lot of extensions there that I need to be using, and I don't know. I might switch to Chrome, but not to Edge. Like I need at least something that's cross-platform, and Edge is not that. I don't know. I'm sure it's okay. I mean, at university, a lot of computers run it, and it seems fine. It looks good. It's okay. I mean, what's a browser? It's a browser. I mean, I don't know. But it's I think it runs Chromium though. I'm not sure. I think the newer Edge would run Chromium. Firefox, yeah, it used a lot of RAM, but it's fast, it's stable, and it's I don't know. It's okay. It's minutia. As long as you get your job done, that's as important as it is. That's it. Like I spent a lot of time before I started to learn programming to use like, yeah, what editor do I want to use? Like, is Vim better? Is that better? I don't know. There was a huge list that I was overwhelmed with which one I used, and in the end I just gave up and used the first one I got installed, which was VS Code, and for now it makes more sense. And I switched back and forth with Vim and realized this one felt better, and in the end it's basically where you feel more okay is the logical option. What was I going to do? Okay, so I'm going to now work on the synthesizer here. So the update function. Okay, I think it's this one. Alright. Let me compile and run for now. It is if you have 8 gigabytes of RAM, sure. But if you have like 32, you don't care. Honestly. Wait, what happened? Was it crashing? It is. Wait, what? I missed something. I think it's yep. Did I initialize those though? Oh, I didn't initialize them. Sure. Well, I too. This computer, like right now, it's only clean because I clear tabs before I start streams, and because I have like a separate user account for coding than my actual personal account. But yeah, if you're gonna using a lot of tabs, then that's a problem. Sure. Okay. So the initialize function here, I want to initialize also these things. It might be fitted to put this into a function. I'm not sure. So that's fine. Yeah. Or might as well just go ahead and buy 32 gigs. Just for the lulz. I mean, why not? It's not that, like, we're not going into less gigabytes usage of RAM. We're going to more RAM usage. The future doesn't look, you know, economic in that regard. Okay, I need to focus here. Well, you don't know. I mean, people thought 10 years ago that, I don't know, 10 gigs was enough. 10 years before that, 1 gig was enough. Like, what do you need your RAM for? I don't know, with more programs, more complicated stuff, we're gonna have more information to store, and I don't know, with more detail in our work, we want more information. It's crazy, you know, it's crazy that program. Like, look at even my code here. Ah, well, it's right. What did I press? Like, even my program uses around 150 megabytes, and for nothing. Like, it's not for nothing. I'm loading the font atlases in loose image forms, and I am also like I'm not being economic in size, and it's just I have more freedom. Like, I can afford to make my program use 2 or 3 gigabytes, especially if it's a game. If it's a game, I can, for now in community standards, I can even go up to 8 gigabytes for a game. Not really, but 4 at least, sure. It should be okay. I'm not gonna make it do that. Which is another reason I have a lot of, like, I have a series for optimization as well. Okay, so I'm gonna need to do this as byproduct amount. It's gonna be an integer. Yeah, no, not really. Which is another problem, honestly, because this produces lazy ass developers that just do not care about performance anymore, and they just write really inefficient code. A Samsung SSD, no. I have a lot of different things here. Like, I have an ADATA for the it's just a thing that came with the computer. I didn't choose it, but I bought what was it called, the one that I bought? Intenso, I think, or something. But no, that's something else. There is Western Digital. Yeah, Western Digital. Yeah, is an M.2 SSD that I used, and there's an ADATA SSD here. And for archives, I use a hard drive. Okay, let me try to compile and run now. Should run. Nope. Again, not. What did I miss? Yeah, I know you triggered a breakpoint. What is the problem? My heap has been corrupted. Oh, yep. Yeah, they really did. And that is the time where we had good developers. We still have good developers. They're really becoming a rarity here. Like, yeah, definitely, it is faster. But not for office work necessarily. Like, I mean, well, of course, but if you're going to be constantly using gigabytes in and out, yeah, you will realize that there's a difference. But when you're working with basically like 100 megabyte of small code, you don't need the fastest SSD in the world for it. It's just there are faster. Like, there are ones that go up to write speed of like 3,000 megabits per second and 5,000 megabits per second. What do you need that for? I mean, only when you're running games that are, you know, that they need to constantly be streaming gigabytes of data a second, then yeah, you need that. But even that, like, those games also are really, you don't need it. That's what I want to say. You don't really need that much. just an SSD basically. Well, not the cheapest one. An SSD with a DRAM on it will make a huge difference. Not all of them have DRAM. Not all of them talk about whether they do or not. It's a bit hard to find one, but if you spend your time to do research, a DRAM will really make things much faster. Yeah, I don't know. Samsung are the best. I mean, such just like hyperbolic claims, I wouldn't really trust in general. They're good, sure. The best, I don't know. I'm not even sure that there is a best. But again, back to the point where like we're talking about. Wait, now this one works. Yeah, we have a problem. We were talking about. Yeah, that developers no longer care about performance anymore, and this is where you have people who write really inefficient code, and they think, yeah, well, my high-end computer can run it, but then you ship that product out, and people use it in all different kinds of environments, and even high-end computers maybe have a lot to do while like multitasking a lot of things at the same time, and suddenly that really bad program could be, yeah, but that's the cool thing about C programming. You have control over memory and you think about memory, so you optimize it to use less memory. This is why games use it, because you have control over how you use things memory wise. I mean, it's not like it doesn't have a memory manager, which is a good and a bad thing, but a very good thing in my opinion. Like right now, the bugs I'm getting right now is memory management. Like right now, I have a dynamic array here, and I am reallocating a space, like allocating memory space for it, for that dynamic array. Wait, how many new dynamic arrays did I add here? So I have one array. That should be okay. Oh, wait a second. I can make this one 2. Is it because they're null pointers? I don't want it to be that reason. Oh, darn it. Nope. Not really. I program for my own projects. I mean, I don't even study programming. This is like a hobby for me. And like I only started like a year ago, 6 months ago. And I enjoy just working on just one project and seeing it to the end. So no, sorry. Yeah, but I also have been programming a lot in the last 6 months, and this is not the first project I have. Like, the first thing I ever did was this thing. Wait, no, was in Codework. Wait, where is the rag? Oh, it wasn't bin here. Yeah, so like it was just me trying like out a lot of things, and like I made a very simple like a game with dialogue, and you know, like you can talk, you know, and you know, you can fart, you can say talk, and yeah, it has even like a save system, like it saves your settings for things, dynamic resolutions, a memory leak detector. Yep, and yeah, but it was like, no, that is exactly the good. Well, I started with Casey Moratori's Intro into C series. He has like a. Let me send you the link. I mean, this is. I mean, if you just watch the main videos, not the Q&As. The Q&As sometimes are interesting, but not always. And he just teaches you like basically what you can do. Just to like how to understand C code correctly, first of all. And then starting from there, I learned how to use SDL, which is very simple. It's not like a complicated thing. But like the only way to learn this far is by doing a project. You have to have like, what do I want to do? I want to just start to program. Okay, I want to have like a ball that moves. And how do I do that? And you start like, okay, how do I render a circle? How do I make a circle move? Other than that, yeah, like I also worked, like I have a lot of half-done projects here because they're all like proofs of concept. Like I had like a two-player game where you like grab something and change size based on where it is, and like, yeah, but it's like it's just something that. How do I pick this one up? I forgot. I think stab. Yeah. Yeah, and that's just like I was trying out what other things I could do, and with a friend of mine, like I have a friend of mine that he is a programmer, and like every couple of weeks we would meet once and we would just like try something new. But mostly it's not like somebody taught me a lot as much as I practiced a lot. I had to. We also like we're working on a ray tracing. No, that's not it. The ray tracer is here, I think. It's a ray tracer and a 3D. Like this is a 3D engine in OpenGL. OpenGL is still something really difficult, and I wanna migrate my own code to it. But right now, like I'm working on my own project. I've been this game that I'm right now working on. I've been doing it for the last 2.5 months, and this is like the biggest project so far, and it's gonna take a lot of time to be done. And right now, I wish I could show you now, but there's a memory oh, it's working for now, but there is a memory issue I need to fix first. Yeah, it's like you can mix things, like add different items, insert them, cook them, and like they have things here, and then you mix them, and there is a simulation of a cell here, and then you throw it in there and it changes things, and no, not really, no, absolutely not. Well, what is there graphically here? I mean, they're just boxes. There isn't, in bytes, there isn't much in it. like here you see there's a RAM usage, the actual RAM usage of around 220 megabytes, and all of this is just the pictures of these fonts that are generated at the beginning. I generate that picture, and I cut out of every letter to print that out. This is all done from scratch. This is not like Unity or a game engine. And oh, there's a problem here. Yeah. Which one? Which one is interesting? Oh, wait, I'm not sure that I solved the memory issue here. Have I? No. Okay, I'm just gonna run it through the application verifier just to make sure that. What is so interesting? I didn't get what you're talking about. The inventory one. Oh yeah, sure. It see? Darn it. Oh, I know the problem. Damn, that was stupid. Here, how many transporters do I have? 1, 2, 3, 4, 5. And I only initialize memory for 4. See, this is the cool thing about C. Like, it can break because you didn't plan it correctly, but it's not. It doesn't hold your hand. It's much more complicated, especially managing memory. But like right now, you tell the program, I want you to allocate exactly this amount of bytes because I know exactly they're going to be filled this much. So yeah, right now if I compile and run again, it should be a bit slower because I'm running the application verifier. Much slower to load. But yeah. So this is a series, by the way. Like you just stepped on something. Like I have a YouTube channel, and there's all like a. For now, this is a 32nd episode, and this is a series I've been working on for a long time. And the idea is that you're going to be like a doctor, scientist, or you have a cell. Like right now, graphically, it's not very fascinating, but I haven't worked on it graphically yet. I'm just trying to set the simulation to work. Like there is a cell inside that has concentration of things. Right now it's broken because I broke it. I'm trying to add new things to it. But it has concentrations of certain imaginary elements. And you can mix these elements, like if you take salt and water and like add more water than salt and then insert them and then cook them until they reach like a certain level. Like right now water is boiling. I'll put it aside for now. I will cool it down so it goes below boiling, and then I'll mix it, and then I have sulfuric acid. And sulfuric acid, then if I add it into the cell, keep your eye here on the concentration, it will go a little bit up, and this will change the pH levels and all that kind of stuff. And yeah, sure, actually I should do that every time here. I should do that in every chat. This is the channel. Thank you for your interest. Yeah, and because like I'm a medical student, and like we learned a lot of shit about cell biology, and like it's finally doing something fun out of it, you know. Thank you. It's really nice of you. And it's a really big project, and it takes a lot of time to get to a point. Like right now I'm trying to get the simulation to work so that I have a balanced cell that keeps itself alive no matter what. Not no matter, but like if you put too much of one thing in it, it can regulate itself back to normality, and just so that it'll be able to tip it out of balance and try to kill it. And like the game would then get you into like you have a sick cell and you have to fix it by mixing a drug here in the mixer, cooking it with a stove at certain temperatures, mixing it, and then you have like you also have an alert system, and you put them in your inventory, and then you put it in your cell, and then you try to fix things. And here, like I also worked on a text viewer and stuff like that. Yeah, that's the idea. Like right now I'm studying anyway, but I don't have much time for a programming job. I already have a job somewhere else, but like it's that could be fun. But my plan is honestly to get a prototype working for the game, so this might take a couple of months more, but I want to have something that is playable, one level, that you have one thing that works, that is stable enough to make a demo out of it. Like, so it's just one demo, and then I'm planning to put it free on the internet, and then make a Patreon account, or like a GoFundMe or something, so that I could have the resources to work on this full time. And then, you know, that would be something. But for now, it's still, well, it's not a buggy mess. No, it's not buggy. It works, but it's still very, very embryonically simple, let's say. So, you know, like I might spend, like last time it took me just 6 hours of work just to get all these cell transporters to keep a balance inside the cell. And thank you very much. I mean, if you could subscribe, that would be really nice. A like and subscribe would be really nice, because nobody watches this. I barely get one person every like 3 or 4 streams, but I stream it just like for fun, because it keeps me organized, because I feel like, yeah, this is a live broadcast. I have to sit my ass down and do things, and it's like an archive. But like sometimes nice people show up, and you know, it will be cool to meet new people. So yeah, I think right now the thing should be stable enough. I think we should have solved the memory problems. No? Yeah, sure. Good. It seems okay. Yeah, totally. There's a lot of, I mean, visually to improve these, because that's still on the roadmap. I mean, there's I think a couple of episodes ago, I streamed from my iPad. I was working on the graphics design of the thing. I know, like, graphically it is very, very simple, but that's the point. Because before I work on how beautiful it looks, I need to first have it working in the background. This is why, like, right now I'm more focused on what the debug informations are and whether I get something to work first. Because, like, right now it's draining its own energy, and that's not good. It has to work better that way, and, you know, stuff like that. And, actually, wait, I think I can show you something. Just a second. Yeah, so I found the image here. There it is. So like I've been working on like designs for like different elements and how they would look and stuff like that, and drawing that on my iPad. And I'm planning like to put this inside. It's gonna look much better. Promise you, it's gonna look much better. But like it's something I learned from working on the first project, where I worked a lot on like the first one looks much better. This raggy one. I even designed a logo for it and all that stuff. It has like an intro and music and all that stuff. But then I discovered that if the game's actual engine in the back sometimes becomes lacking, you have, in order to fix the problems that arise out of maybe like, hey, I want to add a feature. Yeah, like if I want to like add a feature to the game, then I would have to scratch a lot of things and reorganize a lot of stuff. So like make sure that the skeleton works first, and then like add flesh to it. Yep. Exactly, basically. Exactly. You're right. Okay, so now it runs. Yep. I got an iPad Pro. Bought it 3 years ago. The first time it came out. The very, very first one. It's really slow right now, but it works. I can at least, like, the pen thing is really good. It draws really well. If there's a live stream for it, let me find you the link. I mean, you can just like scroll through it and see what I'm talking about. I mean, here, like, I design, like, I do the art design live also as well. Draw it, and you know, might be interesting. It's all in this. It's all on the channel. I think there's a playlist also as well on the channel. Yep, it's the Apple Pen. I think it's this one. So it's really old, but it works. It was also overpriced at $100 for fuck's sake, but it was good. It is good. It still is good. I mean, for a tablet, I would not choose anything other than an iPad Pro just for how good the drawing, and there's like a Procreate, the drawing app on it is amazing. It's an amazing piece of software for $10. Crazy. It's Apple level, if we may say that, aesthetically. So what university do you study? Or computer science? It's called Procreate. So the e-synthase is no longer necessary because this one's producing Arvinium. Now I need to make everything use the e-consumption, so I need to work on the update function now. So Calgary, where's that? Oh, Great White North. Hey, how's the weather up there? I'm in Berlin, Germany. And it's pretty nice. I don't want to go outside. So, wait, where do I take the energy? CE total, there it is. Okay, so instead of CE total, it would be C elements no C elements Arvinium. How far are you? I mean, what programming languages are you good at? I mean, are you any good in C? Or no, wait, does this one have an amount? Yeah, dot amount. So it takes away from the Arvinium. This one is the transporters. Now here, this is for the enzymes. Okay, so I check if the concentration is larger than the target, then skip. That doesn't work if you're trying to sync the concentration as well. That's another thing. How would I do that? I have to rewrite that again. So if the amount is larger than 0, then take part of the yes times the speed. This will have to change. So you will take that minus equals the enzyme reactants amount. Yes. until byproducts I. If byproducts I is 0, then that's also okay. Now here, reactants, and here byproducts amount. Of course, I initialize byproducts as 0, right? Yes, so if I don't increase it, then it's just gonna run. It's perfect. Okay, so C elements, enzymes, product amount, plus equals the speed, sure. And you take away, okay, sure. I'm just gonna take this one out. And let's see how this one looks at. Python, a little bit of C, C++, most likely just do it. Oh wow. I am an idiot outside anything but C. I have no idea about anything else. It's the first language I've learned, and it's the only language I've learned, like C and C++. Because I just wanted to, like, I want to program a game. And for games, that's all I want. Of course, there's C# if you're going to be working with Unity. But I didn't want to do Unity because where's the fun if you're not going to be programming the engine? But hey, that's really cool. I mean, this shows, like, I haven't studied this. I'm not studying this. I'm just the hobbyist. So, like, there's a lot of stuff that I haven't learned. But I'm just, like, learning exactly what I need and nothing more. Okay, well, I want to actually test. Okay. This should maintain an 8%. That's good. But why is this one jumping up to 50%? This is wrong. This is also wrong. What's going on? Ah, dude. Yeah, I've heard that as well. Yeah, I've heard that. I mean, they say, like, if you know this, then everything else should be much easier. It's just basically because, like, just because of all the memory management, I guess, that you have to do. You have to learn. I mean, like, one time I tried to learn Python, and there's a lot of things missing, I feel, like, from the language. That I feel like, wait, what, but how do I do that? And like, no, you can't do that. And yeah. Okay, so what is happening right now? Let's go back to the transporters. So in, out, 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 out. Trying to keep 0.9, trying to keep 0.8. From the transporters I, if it's in, out. Okay, I have to clean this up, so I'm gonna put these in a function. Or later. Half later. Because I don't know. Okay, so let me see if I can recreate the behavior. Really? What? How do you store information then on like larger scale? Like if you say you have a... How do you do arrays if you don't have arrays? Oh yeah, lists, but how different is that really? Wait, I can reproduce the problem. It's increasing. Why is it so crazily increasing? This is wrong. Should be decreasing, motherfucker. What are you doing? I'm gonna have to step through this probably, but wait, so this is gonna be in out, right? Those two are in out, saltrium and carbium. Okay, so if it's in out, it's gonna check the difference. The difference is the type, the concentration of that type, which should be updated every frame, which is right here. Sure. Minus the target concentration. Right? That will give me the difference in concentration. Now m equals the difference divided by 0.001. Yes. Now if the difference is less than 0, if the target C I guess that makes sense. But you can't like write standalone programs in Python. Like it's just like embedded things, right? I mean, or you also, or other you have to have like a thing that carries it, I guess, which runs in C, I think. I guess like it gets the job done. It's just like to the point, which makes sense. I mean, you want to do it as fast as possible and as efficiently as possible, just like here. And since like not many people care about it, like we don't care about performance that much right now because we have such beast machines, we can just like, yeah, fuck it, let's go. Okay, I am a bit confused here. How do I do this? Why is this happening? Okay, I'm gonna step through it because I don't know what the problem is. Okay, so update, what line is this? 1293. Okay, so let's see here. Run. Wait, it's not running. Oh yeah, we have to compile again. Build. Okay. So what's the type? The type is saltrium right now. I equals 0, the first one. Right? Right. Now what's the difference? It's negative because the current concentration is 0.3 and the target concentration is 0.8. That is wrong. Wait, why is it like that? 0.3. And what is C total V? Oh. Yeah, they're just a tool. We're all tools. There they are. So there's probably a problem here. I have to check it again. Okay, what's total V? 14,500. Is that correct? Yep, I agree with you. Totally. So how much water do I have? 5,000. Yeah. It's probably that. 0.9 of that. I mean, if I add these up, there's 10, 20, 30, 40, let's say. 40% plus 5,000. No. Yeah, it makes sense. It's much easier to access. A lot of people wouldn't give up so fast trying to work with it, I guess. Okay, this is also wrong, probably. Let me run it again. Total V is 0. Elements I. $5,000. What is the second? Is this Celtrium, the second one? Second one should be Saltrium. Wait, the first one was blank. I initialize water as... Yeah, no, it's okay. And I is 2. Yeah, sure. Okay, that works. So 4,500 though. Is that true? 0.9 times V. Oh, it's 0.09, not 0.9, you idiot. Oh, darn it. Yeah. That is... What am I doing? Okay, so this should solve one issue. Now if I take this breakpoint and break here, total V is gonna be... Yeah, this makes sense. This makes sense. And alright, so the concentration now would be different. Okay, so now if I skip to here, the concentration is 0.06. Target is 0.8, which is wrong. I see. Oh my god, that's the same problem again. What are you doing? This is percent. 9%. 0. Okay, so let's run it. Okay, so by the way, finally you can see a demonstration of what I'm doing. So as you can see, the cell tries to regulate itself to stabilize at a certain level. Like right now the cell volume is increasing a lot, but that also should be stabilizing. There's a lot of things to stabilize, but if I run it again, you can see like it just attempts to reach like whatever number I told it, which is like 9%, and it's now at 9%, and it stays at 9%. But we're producing like there's a leak somewhere. I want to know which one is causing it though. Which I'm pretty sure all of them are running, probably. Actually, if we have a fat burners, their goal should be to make it at least less than the goal of others, right? That would make sense. I mean, the basic burner here that takes Certerium should try to keep it at 15%, sure. Now the rest. Thank you. Yeah, it's fun because like I feel like at least I can do something about it. Like it's just I'm trying to like make it as close to reality as possible without actually working with reality. And it's a decision I had to make a lot early on. Every time I talk to a person about this game, they say like, "Well, why don't you use real elements? Why don't you just when you know what real elements are being used, why don't you use that?" And the thing is, I don't want to fall in the same trap a lot of medically oriented or like biologically oriented games try to do, is that they try to be educational, but then they fail at it because in order to accurately simulate a body or an animal or a cell, you need supercomputers because there are millions of different enzymes and different molecules at a time. Like labs in MIT and whatever focus on this for 10 years to just figure out and try, and still we don't know everything. So even if you run the most sophisticated simulation of a cell, you wouldn't be accurate because we don't know everything. So cut all of that and just make as simple like as 10 to 15 different things, and that's it. Like for now, there is a cell. Like in this cell, we take saltrium, which is basically salt, carbium, which is basically carbon thing. You mix these and you get certerium. It's a made-up word for just like something sugary that the cell burns to make fuel. And by doing that, you have acid. And that acid gets pumped right out of the cell immediately, as you can see here. It just immediately, like, it's 0.0%. It's very minute, the amount of it, just to keep a pH of the cell stable. And yeah, and if you really want to accurately do it, it won't work. Okay, so what I'm trying to solve right now is this, because like I added an enzyme that makes. Oh, actually, I should maybe print out how much fat I have and how much fatty acid I have to see how much activity of that I have, because I'm practically blind. So I'm gonna go to the debug. Carbic acid. I'm gonna add fatty acid, inside, outside, and just make this fatty acid and just fat. But here there is no fat amount on the outside of the cell, only inside the cell, because there is no pump that pumps from the outside. But I'm gonna keep it just in case we add it later. Okay. So yeah, let's run it again. Build run. Yeah, as you see, that this is wrong. You shouldn't be constantly making and burning fat all the time. I mean, even fat, it's increasing in the cell a lot. This is not ideal, because fat should be like a secondary measurement that the cell executes when it doesn't have enough energy. It should be storing extra energy as in forms of fat, but why is it taking up so much energy? Why is it producing so much energy? There's a lot of things that are out of whack here. Okay, so which is a problem. Okay, so I'm gonna go through them again. So I have one enzyme here that takes saltrium carbium. Byproduct is carbic acid, sulfuric acid, and produces the sugar, which is saltrium. And this one takes arvinium, which is the energy thing, and makes that into fat. And it tries to keep arvinium as low as possible. Which makes a bit sense. But like 15% is not... Like maybe we can make it to be like, just try to keep it above... Well, target C is a bit hard. Maybe like there should be a threshold, a range. A range would make more sense actually. Will give me more. It will give me more playroom to know like how, because I have right now the system works as there is just a target concentration that you're gonna keep it just there. But what if like I want to just like don't kick in all the time, don't run all the time, only run when you need to run. Just add a little bit of a playroom so that increase and decrease would be tolerated. Okay, so I'm gonna do that. Target C, I'm gonna change that to target C up and target C. No, upper value. What do you call it? Target C. Where the range is. What would you call these? Yeah. Chemistry, I think, is just a misunderstood science. I mean, if you like computer programming, theoretically you should like chemistry because it's logical, it's simple, it's math, it's math and logic, and it follows rules. Why wouldn't you like it? But the thing is, I think many teachers suck at teaching it. So we just all end up having an adverse reaction. No, keep it away from me. And honestly, in my school, I had to. Yeah. Okay, so I'm gonna say A. Okay, it's then called high-low. So the high value target C and the low target C. Okay, so gonna give me a lot of squiggly lines. That's okay. So Certerium. No, why is it German? High and the low value. So the upper threshold would be 0.11 and the lower threshold would be 0.10. Gotta keep it that. So like you're gonna try to squeeze it exactly there. The arvinium can go anywhere from, I think they should give it high and low. So I think here is where we get like to design which one kicks in first. Because if the Certerium has a much less tolerance of how wide it gets, like it gets kicked in much faster. They both should share the same upper value, or maybe they should be kicked in at different times. That would be cool. So maybe like the fat, where you produce fat out of arvinium. Yeah, but in my experience, it's really mostly just a teacher. I sucked at math at school for the majority of my school times until like 11th grade, 12th grade or something. Like we got a really, really good teacher, and suddenly I aced in math and it was my favorite subject, and I wanted to just like, I became like a tutor afterwards in math. And it's just when a teacher really can get the idea across to you. Oh, zoology, no thank you. For me, zoology is it a dog? Is it a cat? Can I eat it? Zoology is an interesting subject, but no thank you. Okay, so what do I do the high and low here? So if I only wanted to kick in when there is way too much energy in the cell. So the high would be, I think, like 20 or 18. And the low would be 11, 10. Like the point where it starts to... So maybe 15. Starting from 15, you are going to be producing. No, actually not. Wait, how do I do the target high and low? How was it? If it's higher than high, you should swing it back to at least high. If it's lower than low, you should push it up to at least low. Okay, so it tolerates up until high, and then it sinks back to high. Talking about arvinium. The product is fat. I'm designing a cell. It's like God designing a cell. You may say I'm doing God's work in this thing. I'm doing God's work. I'm designing this cell biologically. Imagine if that's how whoever created us designed us, like, or like, if you believe in God, or just a program, simulation. So high, low. So let's say the concentration is way too high. You try to get it to the high. Now if it is below the high, between the high and low, nothing happens, because now it's burning. If it's below the low, should also not do anything, right? The problem is I have two different kinds of things that are dependent. Like, is it dependent? Does it push up or does it push down? If it pushes like for now, like for this example, this one depends on how much arvinium there is in the cell, and then turns that into fat. So if there's too much arvinium, it turns that into fat. The others are the other way around. If it's way too less arvinium, then it produces them. So how do I do that in code without designing way too many cases? Thresholds. Forget it. I'm gonna keep it back to target C. I don't like. Okay. The target C is the threshold. And this one is 18. Target C shouldn't be called target C, actually. In this case, it should be just threshold. Threshold C. Wait. I want to rename, not just edit. Yep. Rename. Okay, so threshold C. Alright, so... And then there's another thing. Like, this one produces... A threshold C is this. Threshold C element. And... threshold direction. Okay, so in the initialization, we are Saturnium. So we have the threshold thing. And threshold direction in this case is up. Which means you try to bring it up to that number. And here, the threshold direction, I mean, I don't think there is any other way than that. You try to bring it down. Now, if you're burning fat, your threshold to that will be, for Certerium is 10, for here it's 0.8, right? 0.08, right? And this is only when in emergencies you would burn fat. And the threshold direction will be then up. So you usually burn like the normal, you create Certerium normally up to a certain level. Oh wait, this is not for Arvinium. So there is another way. There is the normal way of creating Arvinium, which tries to keep it at, let's say, 12%, and its direction will be up. So anything below 12%, it will bring it up to 12%. But by that time, but only when it hits 0.0, it's only when it hits 8%, where the fat starts to be burnt, because they want to. The cell should start thinking, okay, apparently I don't have any other stuff, so I'm going to start burning fat to produce the energy. And until it gets to 0.08 and stops burning anymore. Otherwise, if it goes anywhere higher than 0.18, then the cell has way too much energy and produces fat. And it starts to put fat. Now, another thing to do is that you give it fat, and it turns fat into fat. It just like stores fat. That's what I mean. Like you increase the amount of fat in the cell gets fatter, and after a certain point, that will be not good for the cell. This is what I'm trying to add right now in the game. Just a simulation of what fat would work, how fat would work. So now I have to program a way for it to handle up and down cases. So let's go into here, into enzymes. Okay, so I need now to check this all is actually the case if I think C enzymes I dot threshold direction equals up. If the direction is up, then you do that. Actually, this should also include this one. Because if you're bringing it up, if the concentration is already larger than the threshold, then don't do anything. Now, let's handle the case that here, else if the direction is down. A lot of these things will flip. Let's go through them one by one. If the concentration is less than the threshold, then you can skip. Otherwise, if the delta P less than 0, or if the concentration is less than the threshold, no, they also have to be flipped. If the concentration is larger than the threshold, increase the speed at which you decrease these things. Now, if you have enough energy, if the enzymes, I don't know, if the reactant amount is larger than 0. So yeah, if you need reactant, then take one of the reactant. If it's less than 0, less or equals to 0, then go there, skip. If byproducts, okay, you increase the byproducts, sure. That's it basically. The rest just runs the same way, I think. Amount plus wait, I think I need to also look at the target amount. Do I have product amount? No, this is just times the speed. Okay, I wanted to, yeah. Of the C enzymes I of the threshold element. So we're dealing with the threshold element concentration here, not the product's concentration, whatever we're checking. Okay, this should be correct. I'm not sure though. Let's check it out. Fatty acid. It's being burnt. Why? We're getting a lot of fatty acid. Because it's running for some reason. So where's the one with the fatty acid? There it is. So if it should bring up to that level. Oh wait, no. Yeah, up, sure. So if it's up and the concentration is larger than the threshold, yeah. You're trying to keep, yeah. That is weird. I'm gonna have to step through it. Oh wait, what am I doing? This is transporters. Oh no, this is correct. The enzymes, right? The enzymes, not the transporters. Here, enzymes. What's the deal? You don't need to do that here. Okay, so okay. The threshold is 0.1, 10%. The concentration so go to the next one. Product is arvinium, reactant it's fat. The concentration of arvinium is 0.07. The threshold is 0.079. Let's skip it. Okay, so arvinium concentration is 0.06. Which is way less. Okay, maybe we should start with a little bit more than. Should also add a lot of fat into the cell. I need to initialize some things. Arvinium, I don't even show it in the debug. .3. You shouldn't be burning fat. Should also not be running. Okay, I'm gonna. I'm gonna have to give them names. Okay, so what do you mean concept of pointers is obsolete? Yeah, but they are very, very, very important. They are just very important. The whole code would not. It would be impossible to run. Like I can't imagine writing anything without having pointers. Honestly, it just feels like basic things, you know. And it's most performance issues come from not really working well with pointers. I mean, this whole thing that I've been working with the last 2 hours is all working with pointers. Okay, why is this happening though? Okay, so the first one works with their Certerium. We can skip this one. The second one, Orvinium. No. Wait, every is an object? You mean everything is an object? Or is it like a keyword every? I don't know. Oh, okay. So the first one, give me Certerium. The second one, and produces fat, right? Yes. So the second one produces fat. The second one should only run when it's over 15, and it's also continue. Third one is Deuterium, the product, and reactant is fat. This is the bane of all. Okay, so threshold is 0.0807. Okay. So, 1. Wait, so where is the... Okay, so... CC elements of fatty acid. One second. Maybe it's just me, an idiot. No, this is fatty acid. What's the deal? So why does fatty acid increase though? Alright. Yeah, thank you for watching, man. It's been really nice. Have a good one. Maybe I'll see you later. Who knows? Fatty acid is not increasing, then what is the deal here? Fatty acid is not increasing, and why is the element fatty acid amount, right? Oh. It's the transporter that's broken. Why is it again happening? Alright, I'm gonna have to loop over the transporters now because they are weird and wonky and funky. sulfuric acid, skip it. Carbic acid, here is the fatty acid. Target C is really small. The amount. There is the issue. This should fix the problem. But wait a second, we should be producing some of them though. Okay, I need to simulate this faster. But that's wrong. That's wrong. That's wrong because the byproducts should be somewhere. And we're increasing. What's happening to the byproducts, man? Okay. You have to check on the byproducts now. Should I not make them... What? Really? Ah. Oh, I'm an idiot. Man. Why is it 0-0 though? That doesn't make sense. Here. I'm an idiot. No, it should work. That's nice. You know what? Just for debugging purposes, I'm going to add a couple of things into the init here. Two, three. And it's gonna be sulfuric acid, carbic acid. Okay, so if I want to mess with them, okay. If I want to add a lot of urbanium, I should turn that into fat. Nice. Okay, gonna handle a couple more. Cool. Well, I gotta go to the toilet, so we'll be right back. I am back. So, for debug purposes, gonna be should also keep the amount of water. Let me see how much water we have in this cell right now. Well, let's make it 70%. So I'm gonna go here. I'm gonna make an in-out water, and you gotta keep it at 72%, right? Hi. Welcome to the stream. I'm doing fine. Thanks for asking. Water over here. And we can see the cell. Ah. What happened? Corrupted heap. Oh. Of course. Why can't it bring it up to... Oh, there isn't enough outside. Yeah, that's a problem we can solve. Okay, so water can't have a threshold. I think I should do the same thing with the target. Target threshold and target direction. Threshold up and down. Okay. Direction is up down. So keep it at 0.9. Yeah, that would make sense. Actually, they should add up. That's the thing. So let's say for every molecule of saltrium, there should be 2 molecules of water, and the same thing for carbium. So 9 times 3 is 27. 8 times 3 is 24. It's around 50%. So, I mean, I could bring this down to 5, and here 4, and this one to 65%. And now in the update function, I have to accommodate the cases. Threshold C. Actually, you don't control water that way. Cells don't push water in and out. It just evens itself out. What triggers a cell? Up, down, in, out. So water is a little bit different. Water has a problem. I could make it so that every time something transports, it just takes water from inside or outside, but this will also depend on the pressure. osmotic pressure is something else. I probably have to work on osmotic pressure now. Let's read it again. Actually, that's what water should be. Water should be defined by how much osmotic pressure there is. So water is something else. Water measures inside and outside levels of osmosis and settles things accordingly. Oh, wait. Should have no more problems. Does this hit this sweet spot? It does. Okay, so osmotic pressure formula. Molecular concentration of a solid. Alright, so let's Van Hoff's index. Well, let's call it 1 then. Van Hoff index, we'll just call it 1. Molecular concentration. Ideal gas constant. 1. This is crazy world. Temperature. .273 plus. Hey, that's really cool. Okay, so now let me calculate the osmotic pressure of the cell. Do I have the sum of the concentrations? sum of the concentrations divided by elements known multiplied by temperature. Okay. Temperature. All right. So let's initialize the temperature, which shouldn't change. And now let's show osmolarity is not being calculated for some reason. Oh wait. I'm sorry, I mean you have to be calculating these somehow, right? You add Sometimes things are just stupid for no reason. Alright, where are we? Update. Alright, what's the deal here? It's afloat. Really, they're exactly the same. That doesn't make sense. Oh, you have to disregard the water. Why would they be exactly the same? That doesn't make sense. Never mind. Nope. What was that? Particles, molar concentration. So the osmolarity is just in this case, in my case, the osmolarity is basically the concentration of everything other than water. Yeah, it works. 30 works. Alright, so let me see if I can bring this up to really high. Okay, it's really fast. Okay, the osmotic pressure would be moved based on how much water. I think so. Let me see if I can do that. This is larger than 0. Ah, damn it, man. Is there a sine function? Okay, that's a little bit too few, in my opinion. Adding more water, I think, yeah. Seven. Okay, how much water should I start with to begin with, actually? Because osmolarity should be... Maybe it's way too much water. Maybe I should make this like 4 and 4. You don't need to have so many Arvinium, do you? Where is that 12? Should we make this one 8? This one should kick out 0, 8, sorry. This one should kick out at 4. Okay, let's try this now. much Soteria. I bring it down. I'm not using any Soteria. Oh wait. Not 80%, also 0.8. What is wrong with me, man? Okay, so now we have the osmolarity. There's something else. There we go. Polarity. I think this is another thing I could be working with. Okay. Now I want to have a way to generate a cell that is balanced. How do you balance it though? So that you have a concentration of things. How do you do that? That's a amount. What if I run it afterwards then, after I initialize all these things? Well, let's say I have actually there's a better way to do it than just need to change the water in the end. %4 critium, carbium 5,4. So 0.04. 0.5. 5, 8, 5, 2, 8. Ultrium here is 5. Here's 4. And the rest. It's already balanced. Good. Oh, there's a couple of things. I don't know which one to start with. Yeah, there's a lot of problems that arose from that small addition of fat. First of all, the cell increased a lot in volume. So a solution of that would be to adjust the celtrium carbium concentration from the outside to reduce the osmolarity or increase the osmolarity so that it will move over. Okay, I need to write these things in the plan for the debugger. Mass mode, add, remove, You know what? I might actually do console commands. I need to simulate the death of a cell. So maybe twice the size, actually. We can do that. Twice the size or half the size. What's the volume? Okay. So let's simulate death. is even more catastrophic. Is less than 4 or it's larger. This is way too fast. They're way too fast. Okay, water should move much faster than anything else, actually. So let me see if I can change that in the update function here. Yeah, well, I know this, but... Okay. That's cool. That's cool, don't you think? The water should flow quickly, that's true. The thing is, it shouldn't survive that much osmotic shock. Like here is as much. Yeah, but so much sultram so subtly. What's the penalty of this? Why are you starting with 0? Dude, why are you starting with 0? Alright. I need to do this anyway. How did that happen? Walk me through it. How did that shrink to death? Why would it shrink to death? It did not shrink to death. It did not fucking shrink to death. Why are you in the minus? Why? Dude, why? What is this bullshit? You need more! Take more! Fuck, the transporters are fucked, man. Ah. I don't know. This is fucking bullshit. Oh, I can't reset the cell, honestly, I can't. There's something wrong about it. Fucking. Oh, well. The transporter just should check whatever we're at and just calculate the difference. That's all you have to do. And the closer you are, the smaller. How do I translate this into a mathematical formula? Sometimes I feel like an idiot, honestly. There's one, I think it's just the second one, right? Yep. Just show me what's going on. It should be working. Also, it should be shocking when I'm getting it so much pure salt without water. I mean, it's not lycra. It shouldn't be double its size, right? Actually not. So if it's like Wait, why is it increasing now? That's weird. Should try to shrink itself back. Why? Shouldn't Carbium try to push it up to... what the hell? In, out. Isn't Carbion in, out? Ah, don't close it. Carbium is in, out. What is the deal? It's exactly the same thing. For some reason, it's not happening. It's weird. Like, let me push some salt in. No, some salt. Back to the game, man. Okay. It's below the number. What is the problem? Why is it not executing then? Here. Do something. It's not doing anything if I put carbine inside. For all I care, I could put 2000s inside. Nope. Like here are 500 RPM. Okay. Why don't you stop at the... Okay. Oh God. I'm sorry. Why does it start like that though? Why does one have so much difference? Why? Why? I do not initialize it as such. It's just that. Is it really the very first thing that runs? Is that? $5.55. When was this deleted? Ja, vielleicht ist für dich. Nee, nee, ich werde auch. Ja. Ach so. Okay, so it seems to be stable. Alright, now let's try to push it beyond. Water rushes right in. Does it stabilize though? It didn't die yet. Does it stabilize? Okay. It should go back to 5,000 though. It's even increasing. I think that based on this observation, I think the logical thing to do is to make the transporters also. What's the different? I want this one though. Ah, shit. is zero acid being produced? Please explain this to me. Why is it happening? And why is it increasing again? Where's all this? Where is? Who is producing deuterium without the sulfuric acids? How does this working exactly? Excuse me. Am I resetting something? God, I feel like I'm blind here. Shit, this again. Why? I broke something. I broke something. Well, okay, I'll make it less. I'll make it zero. I'll make it zero, for fuck's sake. Let's see what happens. Will you do anything? The transporter... How does that work? Where are they disappearing? Oh god, this is torture. Why is this? Fucking fuck. 5.5 hours. Damn it. It's not gonna. Nope, it is. I don't want to stop here. Just stop here. Garlic acid is number 2. Yep. Fuck. Why doesn't it maintain? The question is why doesn't it maintain it? think the problem is basically, simply put, there is always a way for me to take on. Like, I'm taking on salt, I'm taking on carbium, and I'm taking on water. I can dump it, apparently, I think. I'm not sure it even does that. What's its goal, though? 0.5 and 0.4. What am I printing at? Oh, another thing. Actually, we're back to the same issue. It's back to the same thing eventually. What is the problem? Let me try to maintain a constant efflux of these two. Probably that would help. I don't know, maybe that plays a role. Who knows? I mean, if I make them really large, we're gonna have the same problem. Oh, God. I don't know what's the problem, and I don't know what's the solution, and this is failing. And suddenly it's a cascade. Taking more of this, which takes more of this, which takes more of this. Well, you need to balance. So you need to stop at some point. Let something catch up. How do you program that? How do you tell to just take a breath and go back? I guess I could just do a bungee thing with Saltrium and Carbium. Just want to see it take a breath. What the fuck? I can't even see it. Jesus. What the fuck? How is it that, how does that work? How is it so that first two? Oh, why are the first two like that then? It's increasing again. It's increasing. Now it's just rolling. It's a snowball. It's gonna explode again. Just stop. I don't know what to do. I'm stuck. This feels really like the same to anything else. There must be a better way to do it. Well, let's see what happens if I keep this running. Yeah, no, don't start. It started. It started. Damn it. Is it fat that's a problem? Please start accumulating fat as soon as, I don't know.